All right, so here's an analysis of my EECS bonus project. I created a sound detection system that lights up varying numbers of LEDs depending on the difference in voltage that is measured. Now, I say difference because I recorded a base voltage that indicates the voltage that the sensor right over here is reading in a quiet room. And in my while loop, I have another reading, and the two are being actively compared. Now, the larger the delta, the more LEDs light up. So it starts from lowest at the top to highest delta voltage right at the bottom. Now, when the highest is reached, the buzzer on the kit also goes off. I have a servo motor, which serves the same purpose as the LEDs. However, but it's an analog version. If it's too loud, it says too loud. If it's too quiet, it says too quiet. So it'll vary in its angle depending on how large that delta voltage is. Okay, now here's the code. The base voltage is exactly right here. These calibration thresholds are important. These dictate which LED will turn on. So looking right here, if we get to 0.26, we're only going to have LED 1 on. If we get to 1.29, we're going to have LED 5 and all the ones prior to it on. If we get to 2.32, we're going to have all 9 LEDs on alongside this buzzer actually making a noise. Okay, so that's the idea there. Going a little lower, I'm going to get back to this loop in just a moment. But here's a graph, animated line graph function, which I'll show you when I demonstrate the actual project. Now, this is cool. This is going to actually show you the horizontal lines for each threshold on our active graph. Okay, so here's the voltage delta, the absolute value of the current voltage, which is being measured actively for each iteration of our while loop, minus the base voltage, which I mentioned above. Now, depending on what the comparison is between the two, voltage delta is greater or equal to the calibration threshold, we're going to have a different n value assigned to our function when we call it, depending on what's happening, depending on the logic. So let's say voltage delta is greater than or equal to calibration threshold 6. Okay, so calibration threshold 6 is 1.55. What's happening here is we're calling the function with n equals 6. So for I equals 1 to 6, we're going to go from element number 1, L1 pin, to element number 6. These are all going to be turned on. So 1, 2, 3, 4, 5, and 6. However, 6 plus 1 to the length of my pin list, which is 9, so 7 to 9, are going to be assigned a value of 0, which is off. So 7, 8, 9 will be off. So that's how that function, the nested function LED state, works. In the future, this program could be better optimized. Rather than using the for function, we can look towards using the par for, which is parallel for. Now with the for function, what's happening is we're lighting LED 1, rerun through for loop. We're lighting LED 2, rerun through for loop, so on and so forth. With parallel for, we'd be able to achieve all of this at the exact same time, which would make the LED lighting a lot more fluid rather than sludgy, I guess, for lack of a better word. Now, if the user presses the button, it'll actually turn off all of the LEDs, writes all of them to off, and also resets the servo position. Okay. So here are those thresholds I mentioned, and you're going to see 9 of them there. The highest one, when the graph exceeds that, the 9th LED is on, and the kit actually buzzes. Okay, let's actually play the song here, and you're going to start seeing the LEDs light up. Servo motor will move. So there you go. Different LEDs are lighting up. Ignore this one. I didn't have enough GPIO slots, and this is one of the LEDs is also connected to the same one as that. So ignore that one there. Here's the servo motor moving. Here's the graph. So we haven't heard any beeps yet, meaning we haven't passed that 9th threshold. There you go. You probably heard that beep, meaning we passed that 9th threshold. And there's another one. There's the LEDs again for you. Now I can pause the video. All the LEDs turn off, sensor resets, and the graph looks like that. Isn't that cool? Now I can end my loop. I can exit out of it by holding this button down. And you're going to see that right at the bottom there. Hold down button to end program, sound detection ended. So I just held that button down. Cool. So that's my code for the bonus project for EECS.